Hey guys, so good day. It's me, your G Sensei. So we have to review the topics in ITCC 42 Discrete Mathematics for us to proceed in the next topics. Okay, so for my students, please refer to your PowerPoint presentations that I have given you. So let's have a review. Chapter 1, the foundations. We have logic and proofs. So of course, first we have to define what logic is. So logic is the basis of all mathematical reasoning and of all automated reasoning. So it has practical applications to the design of computing machines, to the specification of systems, to artificial intelligence, to computer programming, to programming languages, and to other areas of computer science, as well as to many other fields of study. So to understand mathematics, we must understand what makes up a correct mathematical argument. That is a proof. So once we prove a mathematical statement is true, we call it a theorem. So propositional logic. Okay, so proposition. So this is the basic building blocks of logic. So a proposition is a declarative sentence that is either true or false, but not both. For example, so all the following declarative sentences are propositions. So first example, Philippines is in the continent Asia. Second, Valencia City is the capital of Bukidnon. Third one, 1 plus 1 equals 2. And the next example is 2 plus 2 equals 3. So again, all that I have mentioned are propositions. The question now is, what is the truth value of those propositions? For example, in the sentence 1, Philippines is in the continent Asia. Of course, we all know that Philippines is in Asia, right? So though the number one statement is, the truth value of that statement is true. Second, Valencia City is the capital of Bukidnon. So as we all know, Valencia City is not the capital of Bukidnon. It is Balay City. So therefore, the sentence 2 or the proposition number 2, the truth value is false. The third one, 1 plus 1 equals 2, obviously it's true. And the fourth sentence, 2 plus 2 equals 3, of course it's false because of course 2 plus 2 equals 4. So next is, we have to consider this, the following sentences. So first, what time is it? Second, read this carefully. Third, x plus 1 equals 2. And 4, x plus y equals z. So sentences 1 and 2 are not propositions because they are not declarative sentences. So of course, number 1, what time is it? It's an imperative. And read this carefully is an instruction. Okay. So, of course, they are not propositions. Sentences 3 and 4 are not propositions because they are neither true nor false. So, note that each of the sentences 3 and 4 can be turned into a proposition if we assign values to the variables. So we use letters to denote propositional variables. So that is variables that represent propositions, just as letters are used to denote numerical variables. So the conventional letters used for propositional variables are P, Q, R, S, T, and so on. So the truth value of a proposition is true, denoted by T, okay, T, tango, if it is a true proposition, and the truth value of a proposition is false, denoted by F, okay, fox, okay, if it is a false proposition. So, definition 1. So, let be a proposition. Let P be a proposition. The negation of P denoted by this symbol, okay, is the statement, it is not the case that P. Okay, so this is the symbol for not. the proposition not P, okay, the truth value of the negation of P is not P. Okay. It is the opposite of the truth value of P. So, meaning, if you have P, okay, if, for example, the proposition P is true, the opposite of true is false, so the truth value of not P is false. Of course, if the proposition P is false, obviously, the opposite is true. Okay. Okay. For example, find the negation of the proposition in the statement Michael's PC runs Linux. So, and express this in simple English. So, solution, the negation is, it is not the case. Okay, it is not the case. Then, the proposition, okay, that Michael's PC runs Linux. Again, it is not the case that Michael's PC runs Linux. This negation can be more simply expressed as Michael's PC does not run Linux. Okay, so definition true. 2. Okay, definition 2. Let P and Q be propositions. Okay, the conjunction of P and Q denoted by, okay, so the symbol for conjunction is this one, the inverted V, or the name of the symbol is caret. Okay, so the conjunction of P and Q denoted by this symbol is the proposition P and Q. So the conjunction P and Q is true when both P and Q are true and is false otherwise. Okay, so again, the truth value of the proposition is true when both the propositions, for example, P and Q, are true. Okay, for example, so this is my example sa atong lesson, no? For example, you have a suitor, okay, for example, and you want bright and guwapo. Of course, this is the topic in conjunction, so and. So, bright and guwapo. So, if nainanguyab sa mga bright, pero dili guwapo, busted. Okay, so that's false. Okay, so, let T, okay, true, sugton, F is busted. Okay, for example, nanguyab sa imo bright, pero dili guwapo, busted. Bright, pero di guwapo ya, busted. So, dili bright, pero guwapo, busted yapon. Samot na kung dili bright, o dili guwapo. So, busted, jud. So, para sugton, it should be bright plus guwapo. Okay? So, remember, the conjunction, okay? Conjunction, in order for you to have a truth value nga true, it should be true for the both propositions. So, in our example, bright and guwapo, okay, that should be true in both the propositions in the given nga guwapo and bright, guwapo. So, muna yung timanan nga, if conjunction and, so dapat true ang both na proposition. Once nga na F isa, at least isa, false na siya. So, okay, next topic. Definition 3. Let P and Q be propositions. So, the disjunction of P and Q denoted by, okay, this time, the symbol for the disjunction is V. Okay, V. So, the disjunction P or Q is false when both P and Q are false and is true otherwise. Okay, so disjunction again. So, okay, in my previous example, katong nakay sutor, okay, nakay sutor, and then kaganiya sa conjunction, and of course the conjunction is and. So this time disjunction is or. So dili na kay ka-choosy. Okay? For example, dinawayab sa imo nga bright pero dili gwapo. Okay, okay na siya. So true na siya. The statement, the truth value is true. At least one lang ang true. So, Na pinanguyab, for example, dili gwapo pero, dili bright pero gwapo, sugton yapon siya. Okay, so, at least, you have to remember in this junction, at least one truth value, sugton na nimo siya. For example, katong example ka ganiya. So, if dili gwapo, dili bright, busted, of course. Because, both propositions are false. So, the truth value is false. So, again, you have to remember in this junction that at least one proposition is true, the truth value is true. Okay? So, next topic is definition 4. Let P and Q be propositions. The exclusive or of P and Q, okay, denoted by this symbol, a circle with a plus or plus sign in the center, is the proposition that is true when exactly one of P and Q is true and is false otherwise. So, in the exclusive or, you have to remember exactly when exactly one of P and Q is true and is false. Okay, so if your propositions are both true or both false, obviously the truth value is false. So ay siya true if at least one is true and the other is false. Okay, so you have to remember that one. Okay, so for example, okay, students in exclusive or example, students who have taken calculus or computer science but not both can enroll in this class. Okay, so here we mean that students who have taken both calculus and a computer science course cannot take the class. Again, maski pag nakatake ang student og computer science or calculus or nakatake siya sa ano siya, if the students have taken calculus and computer science, dili siya pwede ka-enroll. If the students haven't enrolled in calculus or computer science, dili gyapon siya pwede ma-enroll. But at least one lang yung na-enroll, either calculus or computer science, the student can enroll. Okay? So you have to remember that one. Definition 5. Let P and Q be propositions. Okay. The conditional statement is the preposition if P, then Q. Okay, the symbol is this one. Okay, so this is the symbol for conditional statement. So, the conditional statement P, if P, then Q is false when P is true and Q is false and true otherwise. So, in the conditional statement, P implies Q, or if P, then Q, is called the hypothesis, and Q is called the conclusion or consequence. Okay, so the statement P, if P, then Q, or simply P implies Q, is called a conditional statement because P implies Q asserts that Q is true on the condition that P holds. So, a conditional statement is also called an implication. So, that's why this symbol is also denoted, or it also means as implies. Okay. So, again, you have to remember that you have to remember in the conditional statement, P implies Q is false when P is true and Q is false. Okay? Okay, next is definition 6. Let P and Q be prepositions. The biconditional statement P, okay, this is the symbol, okay, P if and only if Q, the biconditional statement P if and only if Q is true when P and Q have the same truth values and is false otherwise. So, biconditional statements are also called by implications. So, again, in definition 6, biconditional. Okay? So, all you need to remember is that it is true if both the propositions have the same truth values. So, for example, if the proposition P is true and the proposition Q is true, the truth value is true. Okay? And for example, the proposition P and proposition Q are both false, the answer is also true. Okay? So again, if it is true if the propositions P and Q have the same truth value. Okay, for the summary of all the definitions that we have discussed. So first, for the not, okay, again, we should review this one. So these are the symbols or the connectives. So this is for the not, this is for the conjunction, disjunction, this is for the exclusive or, implication or conditional, this is for the biconditional. So for the summary, okay, for the not, so answer is opposite of the proposition. Okay, so if the proposition is true, so therefore the truth value is false and otherwise. Okay, for the conjunction or and, at least one false, at least one of the proposition is false, the answer or the truth value is false. Okay, for the disjunction or at least one true proposition is true. Okay, so at least one true, the truth value or the answer is true. For the exclusive or, if both propositions has the same value, if both propositions has the same value, for example, truth, P and Q propositions are both true or both false, the answer is false. Okay, and for the implication, truth if both propositions are true and P is false. Okay, true siya for the implication. The truth value is true if both propositions are true, meaning the propositions P and Q are both true. For example, the truth value is true, and if the P proposition is false, that is the only time nga true ang answer. And lastly, for the biconditional or if and only if both propositions has the same value, the truth value or the answer is true. If you have noticed, the biconditional statement is the opposite of the exclusive or. Okay, exclusive or, if both propositions has the same value, answer is false. This time in the biconditional statement, if both propositions has the same value, answer is true. So that's it for our lesson for today about propositions. So please review your handouts. Later I will upload a video for our next topic, for our next review, okay, topic, before proceeding to new topics. Okay, that's it and bye.